Hey everybody, welcome. Thanks for waiting for us. Welcome to Beyond Just Observing, protecting the whole software supply chain. I'm Andrew Krug, and I lead the security advocacy team at Datadog. And I'm joined today by my colleague Zach Allen, who's the senior director of security research at Datadog. Together, we make up kind of two sides of the same coin. We're collectively the team that publishes all the content on Datadog Security Labs. So if you have not heard of Datadog, and I am just curious how many Datadog customers we have in the room today. Okay, the majority of folks. How many Datadog security customers do we have in the room today? All right, well, welcome. If you haven't heard about how we help you with security, basically, we're trying to unify dev, ops, and security. Traditionally, those are siloed teams, but we bring them together sort of around their shared use cases to help them identify specific issues, triage faster, and collaborate. So to put simply, Datadog breaks down those silos on one platform with unified correlation and shared visibility by helping you detect, protect, and respond across every part of your stack, code, runtime, and cloud. And I only mention that because that is kind of the theme for how we're going to set up the story that we're telling you today about software supply chain security. So if you think about it, code, runtime, and cloud really are the three parts of the software supply chain. You have code that's being built by your engineering teams or in a CI/CD pipeline. You're operating it on platforms like EC2, serverless functions, and more. And that's all on top of your cloud provider. In this case, that is the AWS cloud for the people in the room today. If you have ever wondered how we got started with software supply chain, I think it's kind of fun to go all the way back to the beginning. And the very first paper on the software supply chain was authored in 1984 by Ken Thompson. And if you're not familiar with Ken Thompson is known as one of the founding fathers of engineering. And he wrote this paper on the dangers of backdoored executables in shared computing environments. And if you think about it, you might argue that today, we're all pretty much working in shared computing environments. So it's kind of interesting how little has changed. But there's also a lot that has changed. And that is the breadth of the types of vulnerabilities. And there are two different kinds of vulnerabilities that we can talk about anytime that we talk about software vulnerabilities. And I like to say that there's ones that are done by you and ones that are done for you. That's a joke. I know, it's Wednesday. So we're going to focus more on the ones that are done for you. So how are different threat actors getting vulnerabilities into the software that you're operating in your production environments today? So biggest differentiator between that 1984 sort of refrigerator-sized computer and today is that today teams are dealing with just generally more technical complexity. You're potentially managing hundreds or thousands of services. You have a proliferation of various languages inside of your environments. Cloud makes it easier for you to run these extremely diverse environments in terms of your application stack. And then we have this heavy, heavy focus on resilience. We've told engineers for the last 20 years, don't run software in production that you haven't tested, and rightfully so. So what do? We pin to the same one version of that software, and then it potentially goes years without being updated because it's actually doing its job. In fact, these problems today are so complex that the Linux Foundation spun out a complete foundation to bring industry leaders and community members together to address some of these problems, and that is the OpenSSF. And we're actually super proud to have joined this working group here. Is anybody here a member of the OpenSSF, participates in that community? If you're interested in supply chain, OpenSSF is a really great place to just gain awareness, education, and also to give back some of your cool ideas as to how we can secure the entire software supply chain. One of the ways that we contribute back at Datadog is through the identification of malicious software packages in the Node and Python ecosystems right now, but we're expanding the language support via a project that we call GuardDog. And if you happen to also be a Datadog customer, those packages that we identify also will surface inside of our findings regarding code, runtime, and cloud in the Datadog platform. And if you also use Cloud Security Management, our CSPM, and the Cloud SIEM product, we'll also add that additional context to the way that we think about criticality, which helps your teams identify, triage, and act faster than they could with those single points of data alone. We'll get into that later on in the presentation. But today, we're very fortunate to be joined by Zach Allen to tell us just a little bit about how we run that GuardDog program and break down some of the things that we're looking for to identify suspicious malware.
All right. Thank you, Andrew. Hi, everyone. So today we're going to talk a little bit about all the interesting things that we see when it comes to open source malware using GuardDog. You can go and check out a lot of this research on our Security Labs website, but we're going to dive a little bit deep here. So whenever I think about finding bad guys, looking for threat actors, I first think about the threat model. And a really convenient and really well thought out threat model, at least for the software supply chain, is a threat model called SALSA, or Supply Chain Levels for Software Artifacts. Basically what it does is it describes how software is packaged and moved throughout a system, whether it's being built, pulling in external dependencies, packaged, and then sent out for people to consume. So I'm going to show all the different ways that we've observed threat actors abusing part of this SALSA threat model. To get back to GuardDog, our approach to identifying threats is to use this open source framework that has SemGrep under the hood. We wanted to challenge how static code analysis tools were used. They're typically done for vulnerabilities. A lot of the malware we were finding wasn't something that was compiled, it wasn't in bits and bytes, and we had to reverse engineer it. It was in Python, it was in NPM. And so we thought, hey, can we challenge this assumption and leverage these static code analysis tools to go and find malicious patterns inside these packages itself? And it turned out it was a really good way for us to do that. And we can find all kinds of different heuristics, such as malicious command execution or overwrites, code execution. I promise I'm going to go over all of these with examples. So it was an intern project in 2022. And I'm really proud about that because it was something that one of our interns identified and thought would be interesting to research. And now it's something that we run in production. It's something that we use to protect Datadog, and it's something that we use to protect our customers. We're primarily looking at the Node, Python, and Golang environment. And since 2022, we've published over 1,700 public malicious packages. So if you want to go and kick the tires on some malware, you can go to that GitHub link right now, and you can go and download them and see how we found them. So we talked about the code, runtime, and cloud, and how malware and vulnerabilities and threats kind of move throughout it. So I'm going to take you along a journey here to look at all the different things that we see throughout these three different scenarios. I like to think about this XKCD comic a lot when I do research on supply chain. For those that haven't seen it, the basic premise behind it is it's a really good visual representation of what a lot of the software ecosystems we deal with in the open source are constructed. And it's really, there are so many packages that are like underpins to some of the most important software that runs in production environments today. And threat actors know this, and this is what they abuse. If they can go and target any part of this supply chain and this dependency ecosystem, they can really get a lot of people to download this malware and run it, and they become victims. For those that are unfamiliar about the package manager ecosystem, this is like a very basic design on how it works. You have a developer on the left. They're building applications. They don't want to write all the libraries to do the things, and so they rely on a package manager ecosystem, which is almost like a social network for libraries where they can search for packages that might be interesting for them, and then that ecosystem can distribute those packages. On the other side, developers sign up, they build libraries, and they publish into this ecosystem. What's nice about this is it's centralized and put in one place, very easily indexable and searchable. So let's go over some attacks that we view within this setup. The first one I'm going to talk about is a threat actor who signs up for one of these package managers and with the full intent to build malicious libraries and publish them into the ecosystem, with the idea that a developer hopefully can search for it and download it unknowingly. One activity cluster, which is just a fancy way for a threat intel and a security person to say threat actor, that we call MUT 8694, which stands for Mysterious Unattributable Threat, dog-themed, Datadog. MUT 8694 specializes in publishing packages over PyPI and NPM. We tracked this campaign specifically over 43 different packages around a week. And what they did is they tried to leverage brand jacking and typo squatting, fat fingering your package to basically say like pip install request, but you may switch a U and an E with the hopes that people download this package. After you download the package and it executes, it downloads 2 additional payloads, specifically Blink Grabber and Scold Stealer. Stealer malware is like an old school keylogger on steroids. And I'll show you a little bit of how that works here. So let's use GuardDog to go and take a look at this. Node Logic was one of the packages that they published into the NPM ecosystem. Here's a tree diagram of basically how it's set up. Not really that remarkable. They have code index.js, package.json, which describes a little bit to the NPM installer how it works and some of the metadata associated with it, and a separate JSON file that's also packaged. Let's run GuardDog on it. Line 1 is how you run GuardDog. You say GuardDog, NPM, I want you to scan this package. And 2 heuristics or 2 rules hit, and these are those semgreps rules I was talking about. The first rule that hit was a common obfuscation method used by malware within that index.js package. Usually in JavaScript, you'll see obfuscated code, but what makes this interesting is that there is a configured post-install hook inside the package.json that you see at line 10. These 2 things together made up our ears prick up, and we wanted to go check it out. Because it was obfuscated, we deobfuscated it, and this is what you're looking at in terms of the malware. So I highlighted in the red boxes the most interesting parts, but basically when you ran npm install node logic, the post-install hook ran and ran this code, and it reached out to 2 separate URLs for executables. Once it got those executables, it ran 2 PowerShell commandlets to download it and run it. And there's some error handling along the way there. But basically, after it ran, malware was installed on these developer computers. Instead of reverse engineering the malware, we did what every good security researcher does. We Googled it. And lo and behold, right at the top of Google, we found the GitHub repo for one of the pieces of malware, Scold Stealer. This is kind of like my favorite thing to do when I'm researching InfoStealer malware, especially it's open source, because almost all of them say it's for educational use only. And I've never really seen it used for educational use. So as you can see here, it's written in Go. You can go and check out all the different ways that you can leverage it for educational purposes, such as checking in on infected machines, the different operating systems and architectures and things like that. When it runs, it'll go into your computer. It will go and find all kinds of things like passwords, session tokens, cookies, crypto wallets, zip it up and put it in a convenient package that's displayed in Discord. And so throughout this campaign, Scold Stealer was distributed throughout these 43 packages, and many victims downloaded these packages across the pip and the NPM ecosystem. There's an interesting cross-section, and it's probably a good assumption on MUT 8694's part, that if you're a developer, you probably have a higher probability of holding crypto, and you have those wallets directly on your computer, and that's what Scold Stealer targets. So we talked a little bit about the abuse of signing on to these different package manager ecosystems and creating accounts for malicious intent. What about if I just compromise the developer itself? The idea here is you find the developer, maybe they have a popular package they're working on, and you can somehow compromise them to insert malicious code directly into their package. Instead of relying on folks to search it and maybe discover it through typo squatting or brand jacking, you're just relying on the brand of that package itself. There's actually a story out today about Solana being backdoored. And there was a Solana library on NPM, and that went through the same type of threat model and exercise where someone managed to introduce malware into it itself. A really good example of this is a few years ago, UA-parser.js, very popular library in NPM, was compromised. There are 3 separate versions that were, malware was inserted into them. And as you can see here, someone opened up a convenient GitHub issue to kind of say, hey, can anyone tell me what's going on? These 3 pieces of, these versions rather have malware installed, what do I do? Luckily, the owner responded, apologized, and kind of gave some hope and at least some instructions on what they needed to do. But I thought it was interesting that they said, I believe someone was hijacking my NPM account. So we're seeing this over and over again. But let's not just rely on GitHub issues. Let's go take a look at it with GuardDog. I managed to find one of the malicious versions of UA parser 0.7.29, which you see on lines 2 and 3, and I ran GuardDog over it. This time, in this specific scenario, a pre-install hook was installed. So when you run npm install UA parser.js, the pre-install hook runs before the whole package is installed, and it runs this basically on the command line to run node pre-install.js. The ampersand basically forks it as well and runs it again. A lot of times malware authors don't trust themselves, so they run the thing a lot of times hoping it gets executed. The pre-install hook is this JavaScript code. Interesting parts are in the red here. It basically tries to find out if you're running Linux or Windows, and then it executes a pre-packaged batch script or shell script, depending on which one of these is running in the current operating system. And so not only was that malicious code introduced to package.json, there's additional malware being ran and packaged with those versions, which are this shell script and this batch script. Here's the batch script. Shell script looks pretty similar. The interesting part, again, is in the red. But as you can see, kind of top reading down, you'll see that it's using several binaries to try to go and fetch payloads. There's a couple executables in there, like gsextension.exe, as well as a DLL that was being installed. Unremarkably, they tried to install a crypto miner. So they tried to make away really fast with some crypto, hopefully that they made a few $1,000s from this. The interesting part is right at the end of that large command in the red box where create.dll is installed. That's actually a piece of malware called Danabot. Danabot was really popular several years ago, like 2 or 3 years ago rather, and it's generally used as an initial access loader. What this basically means is it runs, you get added to a botnet, and then this ecosystem of criminals tap into that botnet and purchase access to go and do things like ransomware and things like that. Another way, instead of compromising a developer, hopefully getting that developer's package into the ecosystem, you can just go after the developer that's building the applications itself. Datadog tracks a North Korean Nexus threat actor that we call Tenacious Pungsan. For those that don't know, Pungsan is a dog breed native to Korea. You're starting to see a theme here. And Tenacious Pungsan, what they rely on is going after developers who are looking for a crypto-related job. And what they do is they recruit them on gig sites, and then they force them to take a coding interview. That coding interview is usually in a GitHub repo that Tenacious Pungsan distributes to them, and that specific repo is backdoored. And the idea behind it is once the developer runs that backdoored repo, there's some stealer malware, which I'll show in a second, but it's also used as initial access for North Korea to pivot into a company. Here's one of the GitHub repos for one of the job interviews. I redacted a lot of the information there just to kind of protect the person that did it. But basically, they git cloned it. And as you can see in the README, they had 2 problems they needed to fix to pass this interview. It's mostly a NPM or node package. And if you run GuardDog over it, it found something pretty peculiar in one of the files. So backend/source/middleware/check API access. And then said it was something obfuscated in there. Let's see if this video works. And press play. So it looks fine when you look on it on GitHub. I don't really see anything that looks obfuscated, but if you keep scrolling, you'll notice that there is a piece of malware there. And it calls out to a domain called ipcheck.cloud on port 3963. North Korea is also very good at keeping track of their victims. This is campaign ID 504, so their 504th victim, basically. And this malware is called Beavertail. Beavertail is used as an initial access loader, just very similar to what you saw earlier. And it downloads another piece of malware that gets even more of a foothold into the developer. You can kind of look at this here if you want to take a look at it a little bit more. But it's very innocuous in the sense of like it's just one line, but it's something that is backed by a nation state. The idea behind this is that North Korea tends to go after and steal cryptocurrency to fund their operations, especially their nuclear program. And they also use it to get additional intelligence and perhaps go for like even larger heists if it happens to be a company that they can go and steal from. All right, we talked a lot about the code. Let's just say a piece of malware makes it through your coding pipeline or vulnerability and it makes it in a runtime. Let's just say it's a misconfiguration. What does that look like and how do the bad guys go out and reach out to you? So in this example, we run a very large honeypot infrastructure at Datadog. We'll run all kinds of cloud-based services. We misconfigure them on purpose. And the idea is we want people to reach out and try to interact with it so we can kind of record what they're doing. In this scenario, this is a Docker service listening on the open internet on port 2375. And we get a lot of post requests to create containers there, which seems kind of interesting. So one of the campaigns that we see quite frequently tries to create malicious containers. And what it'll first do is see if it already infected you. So this is a post request to check to see, hey, are there already elements of my infection that I've already ran on this? And if there isn't, a separate container is spawned, and it runs that curl command at the bottom. That curl command goes and retrieves a shell file, and it pipes it to bash, and then all the fun starts. Downloads a bunch of malware. A lot of it really focuses on secrets and secret collection. So this is just a kind of a list of things that it's interested in. Notice that it's everything related to database secrets, private keys, cloud secrets, and things like that. And what it does is it packages those up, and it sends it to a command and control server controlled by the threat actor. This is kind of like some of the code that you can see here. Basically, once it finds it, it reaches out via curl to elite.dbs.anondns.net. And so you leave this open, it's misconfigured, someone can take advantage of it, and they can steal secrets from you. They also do a couple things like run a crypto miner, and they set up a lot of their malware in a way to basically worm itself and scan the internet as almost like a zombie to go and infect more hosts. This is a picture, at least from this campaign, of a lot of the hosts that we've seen check into our honeynet. The lines that you see are dwell times. A dwell time is when a piece of malware runs on a machine, and it's basically the start and stop time of when that malware was ran. And as you can see, some last for a long time, some are little blips, and this is just kind of like the ephemeral nature of the cloud. And so by leveraging that worm-like capability, they can spread across a lot of different IP addresses. So this malware got on maybe a misconfigured Docker service or a Kubernetes cluster or things like that. It eluded secrets. So we're going to look at how this threat actor performs what we call lateral movement. Once I get access or a foothold into an environment, how can I get more resources and move deeper and deeper into that cloud environment? One of the pieces of malware that was dropped on the previous campaign reaches out to a separate command and control server, which you can see as the IP address right there. It does some basic housekeeping. What is the IP address of this infected machine? What is the SSH config? As well as it takes the secrets and it drops it to that IP address. And this is just one of the examples at that curl command at the bottom of it placing all this information at the server at in.ssh.php. If you reach out to this IP address and you take a look at some of the routes that they had configured, they also misconfigured their command and control server. So we actually got a list of all the files that are being hosted on that command and control server. And so one of my favorite things to do when this happens, a threat actor misconfigures their cloud service, is I download the bash history. It's just a great way for you to kind of check and look how hands-on keyboard activity works from the eyes of the threat actor. And basically what this threat actor was doing was stealing all those keys that I talked about before, looking at things like the stolen AWS access keys, configuring the AWS CLI to use that access key that it just stole, and then it ran through a number of commands to persist. So if they lost access to the victim access key, they had additional things they could rely on to maintain a foothold into that environment. The old adage I like to use is 2 is 1 and 1 is none. So if you ever hack into somebody, make sure you create a second account just in case you get kicked out the first. What's nice about this is that you can view this within AWS, especially in CloudTrail. You can go and look for create user events, specifically with those request parameters, AWS_support. I promise you that's not AWS support. And what's cool about this is we collect a lot of this intelligence, we push it back out into our customers' environments so that this now turns into a really high fidelity rule. Let's look for create user events with a specific parameter of AWS_support, because we know that this is a malicious actor. Same thing with create access key. And so again, this is more persistence mechanisms that they use. They create the account and they create the access key. They also try to do what's called privilege escalation. Of the current permissions that I have, can I get even more permissions from that? This is a pretty tame example because it just assumes that the access key that they stole has administrative access. But again, once you start putting all these things together, you start to see a timeline of this attack where they steal the key, they create the user, they create the access key, and then they try to escalate privilege to make it an administrator account. So I walked you through code, runtime, and cloud. What do the bad guys do if they get access to any one of those things? And the further out you get, you'll notice that they tend to jump between the three different environments. They may get access to a container, steal something from that container to get access to the cloud. They may get access to your developer environment, and maybe you install a malicious package. How many people here have API keys on their laptop right now that they use while developing? Those are things that they look for, and they can pivot and skip the runtime and go directly to cloud. We've also seen them start with the cloud and go into runtime. So it's a convenient model when you're thinking about securing these things to make sure that you know that any compromise of one of those environments can lead to a compromise of the other. So a misconfiguration in developer code or an infected developer can allow threat actors to reverse through your software supply chain. Finding these security issues, threats, or vulnerabilities in code really, really puts a cost on threat actors who are trying to compromise your runtime in cloud. So stopping it in code is a very, very good strategy if you want to prevent and reduce the blast radius of vulnerabilities that make it into runtime in cloud. For Datadog security research, at least in the last 3 years, we have seen threat actors increase their knowledge of the cloud attack surface and the software supply chain. They specialize in one or many of these parts. You can think of a lot of these cyber criminals and even nation states as specialists, and there's an ecosystem behind it. So just because someone may get access to your laptop, they may not know how to use the cloud. So what they do is they sell access to that cloud. Or it might be any number of the cloud runtime and cloud parts that they specialize in. And lastly, if I had to give any parting advice, security, me, I need help. I need help from developers. I need help from ops. I need help from SREs. I want to be a guidance counselor, not a hall monitor, right? I want to stop these things before they make it out to runtime and cloud, and I want to make sure that we can do it together. And so that's something that we try to specialize a lot in Datadog and try to work together with our internal teams and with our customers. And with that, I'm going to hand it back off to Andrew.
Thanks, Zach. I just have one question for the folks in the room. Would anybody like to apply for my fully remote engineering role? If it sounds too good to be true, it's usually too good to be true. So let's talk a little bit about all the different ways that you can protect from these kinds of protect against these kinds of attacks using Datadog. So identifying threats is just one piece of the puzzle, right, when it comes to the supply chain. Once you do identify those threats, and those can be malware like what we just walked through, but there's a variety of threats that come from supply chain. Some of them are not always obvious, so we're going to walk through those. This is where Datadog's software composition analysis product closes a very major gap. Data that we take from SBOMs generated in CI allows you to quickly see how many vulnerabilities are in your code base, and more importantly, how many are live in your environment. This is a force multiplier for teams in terms of how you can prioritize and act on these findings. A single SBOM all by itself, not super useful, but a single SBOM that's correlated with information about your entire environment, that's what's going to really help you mitigate risk. So we recognize that shifting left is not the only thing that we need to get kind of the entire context here. We need to, in order to be effective, we have to observe the entire software development lifecycle. And that could be anything, again, from malware to undesirable open source licenses, the ones that we don't really generally think about. Yeah, uncommon risk. So let's take a look at what this looks like inside of Datadog. So what you're seeing on screen here is the Vulnerabilities Explorer inside of the Application Security Management product, where developers get one view of all their repositories. If you click into repositories, you can see the specific type of vulnerability that's been identified, whether that's done by you or done for you. So in this case, the example is a remote code execution vulnerability. It identifies it based on file and line number. So already we're going pretty fast here in terms of understanding what we need to do to fix that problem. The other interesting piece of context here is that we are actually also able to see runtime vulnerabilities, and that's the additional context that we have from observing the things that are actually running on the box. So that's the state of the thing today, not the state of the thing when we generated the SBOM, because sometimes that diverges from the time that it ran in CI. If you're really, really successful and your application runs for a long time, you lose some context. So having both sides of that is really, really critical. So to recap there, what we're trying to do more than ever is prevent vulnerabilities from entering the environment pre-production. But what we're acknowledging is that we almost can never do that 100% of the time. So we need that additional lens of context to know what vulnerabilities are present inside of the production environment. Now, where teams really struggle in using open source projects or DIY solutions is that they have no context of how urgent it is to act when a vulnerability is identified. And if you follow our research reports at Datadog, we do a report every spring that's called the Datadog State of DevSecOps. And what we did is we decided that we would do an analysis of all the vulnerabilities from all the environments that we could observe, and we would look at those in context and say, how urgent was it to actually act on that vulnerability based on other things that we know about the environment? Like, was that workload exposed to the internet? Like, was that an exploitable path inside of the code base? And what we found is that when we adjusted the severity based on the understanding of the runtime context, a very, very small percentage was actually needed to be prioritized at a high or critical level. So if you look at this chart here, that one down there on the right, more than half is the category that needed to be actually acted on. So that's less than 10% of the aggregate, which is much more palatable, I think, if you only had to act on 10% of those total findings. So this unique solution is actually built on top of Datadog APM. So if you use application performance monitoring today, that is the same system that we use to derive that additional runtime context information and then adjust that score based on what's really happening inside of your environment. And as mentioned, we detect vulnerabilities using the combination of SBOM and runtime data. We keep the entire chain of custody for how we do that in platform. So what you're seeing on screen is all of the reasoning as to how we adjusted the criticality. And what's really unique here is that final calculus that we call the Datadog severity breakdown. And that score is derived from the totality of the data that we have access to inside of that one platform. So it's both shift-left data, runtime context, and threats that we detected in the environment. So you might see some interesting things on that screen that we'll get to in just a second. But what's more important here is not just the fact that we can help teams prioritize, it's that we actually have information that shows them how they can remediate that inside of their environment. Because not every engineer wakes up in the morning and says, you know what I want to be an expert at? It's actually remediating security vulnerabilities. And that's just one piece of the puzzle, right? So you potentially have a very large environment. You have thousands of systems. Sometimes it takes you a long time to roll out a patch across your environment. And so that's where a new feature called exploit prevention actually comes into play. And if you're using our runtime application self-protection or RASP, what we can do is we can actually identify those exploits and we can block them or effectively build a fence around your application while you are patching and remediating vulnerabilities. So what you're seeing on screen here is a little animation of how it actually works. All we're doing is intercepting the HTTP request and then comparing that to a database of signatures. is a very common database of signatures, but it's very, very effective at shutting down access to these vulnerable code paths inside of your application. So now we did promise you the full set of defense in-depth tactics across code, runtime, and cloud. And if you're a cloud security practitioner today, you know that the blast radius of any one of these vulnerabilities is dictated by the configuration of your environment. So the more secure the control plane configuration is, the less lateral movement potential there is inside of the environment. So things like incorrect IMDS versions, IAM policies, accidental public exposure, these things really, really matter when we're talking about how impactful a specific incident could be. So this is where it gets really interesting, because you could have a specific alert like this, and this alert becomes more valuable the more data we have about the environment. And so we combined CVSS, which describes how impactful a specific vulnerability is, with EPSS, which says how likely is that to actually be exploited. And that calculation involves things, again, like is that thing attached to a public load balancer? So that determines the likelihood of exploitation. We marry that with the severity of exploitation, and we get the Datadog severity breakdown, which is actual risk. So what you're looking at here is a screenshot that shows us every step of how that's calculated inside of the interface. So is this in production? Is it actively under attack? That's a really cool one, I think, that we added, because it's always interesting to take action on something that's actually actively being exploited. Is it publicly accessible, and does it contain sensitive data even? So obviously an application that contains sensitive data is going to bubble up higher in the list for you than something that doesn't. So if you're a visual person, let's just imagine, for example, that you have a production service. It's spread across 2 availability zones. You have a front-end service and a back-end service, public VPC, private VPC. If you are writing in the same stack, you might have that same vulnerability present at every tier of your stack at the same time. So what this does, it gives you a really clear picture of where do I start applying the mitigations. But taking that one step further, we can obviously act faster with more context. The next piece of the puzzle is we want to help identify interesting attacker behavior inside of the environment. And so if somebody does compromise one of those vulnerable applications, we want to actually track what they do inside of the environment. And that's where the attack paths feature comes into play. And this leverages a combination of data about the configuration of the environment, but also any logs that you're ingesting into the environment, like AWS CloudTrail. So let's just do a quick analogy here to describe how an attack path actually would work in a real-life example. Imagine you live in a neighborhood, a relatively nice neighborhood, that started to have some issues with robbery. One incident of somebody running up to a door to check to see if it's locked is not in and of itself super, super interesting. That's not something that we would, for example, want to wake up someone in the middle of the night for. But if somehow we could observe and collect data from every doorknob in that neighborhood, we could know that the same threat actor went to 4 different doors in the same neighborhood, found one that was open out of those 4, stole a spare key to a garage, and got away with a stolen vehicle. But unless we were actually able to observe the state of each step, we actually couldn't prevent that theft before we actually observed the car driving away. So it's tracking the state of multiple steps inside of the same complex system that looks interesting. So if taking that back to cloud's really no different than that example. We look for interesting combinations of threat actor behavior, like exploiting an SSRF, pivoting using stolen credentials, persisting or stealing data. Each one of those events alone, not interesting enough potentially to wake somebody up in the middle of the night. But those events in concert justifies that maximum level criticality rating, and then that's the thing that goes into your paging pipeline. So just to summarize here, you've seen us demonstrate methods to detect using SCA to detect pre-production, runtime context to identify in production, and also how to act faster by enriching that criticality with the data from cloud configuration. So that's via the Datadog Cloud Security Management product, or the CSPM that we have. But we have one more thing to show you, and I know that we're both really excited to release this today, and that's a brand new open source project that we're going to release here at reInvent. And that is this Datadog Software Supply Chain Firewall. The Software Supply Chain Firewall is a free project. It's built on top of the detections from GuardDog you saw earlier in the presentation, and it's going to protect you from all those types of attacks that Zach demonstrated on screen, and also future attacks that we identify. So as we identify those things, this tool just gets better and better as time goes on. So the supply chain firewall prevents the installation of malicious packages by wrapping the npm and py commands to keep problematic packages out of your projects as early as possible. So today, it will reject 35,000 malicious packages that we've identified from sources like OpenSSF, OSV, and of course the Datadog malicious packages repository that is also available on GitHub for study. So if you want to see that in action, doing what it does best, it's right here in the demo, preventing an engineer from installing a backdoored package. So this could be anything from intentionally installing a backdoored package to just a typo on a commonly misspelled package in one of those ecosystems. And if you happen to be a Datadog customer as well, it'll ship logs from that instance of the software supply chain firewall back to Datadog, so you can actually measure how often this is happening inside of your environment, effectively turning all of your engineering laptops into additional sensors you can use to collect telemetry. And with that, we'll bring Zach back up here to the stage. I want to thank you personally again for being here with us today. If you're on site, you can of course still meet with us at reInvent, so that's that QR code on the left if you want to book a meeting with us. The center one is of course the available today Datadog Software Supply Chain Firewall. And to keep up to date as well, if you're interested in some of the things that Zach showed on stage in terms of our deep dives and write-ups, you can read that on Datadog Security Labs, and we actually just launched this year the Security Labs newsletter. So if you're the kind of person that likes to get a monthly email with a summary of all the cool stuff that's coming out inside and outside of Datadog, we've got that newsletter that you can subscribe to. And we'll also be around in the hallway after the session is over to take any questions, but we do have some time for questions in the room here. And the way we're going to do that is that we will run a microphone out to you, and then you'll ask your question, and it'll be part of. I think we're out of questions, but again, we're going to be around all the rest of the week if you want to talk with us. I know that this is a sponsored session, but please do fill out your session surveys from this. I read every single one, believe it or not. So please do take the time to push the buttons in the app. And thanks for being here with us again today.
Thank you all.